This is the Mechanics booklet, question 6. State two vector quantities. Very simply, for the vector quantities you could have velocity, acceleration, force, displacement, or there are some other possibilities, but you must have two to get 1 mark. Scalar quantities, some possibilities are speed, distance, mass, time, but there are others as well. Part B. The helicopter shown in the diagram is moving horizontally through still air. We are told the lift force from the helicopter's blades is labelled A. So have a good look at the diagram. Here you see the lift force shown. Two other forces are shown, B and C. First step then, you're asked to identify these forces. So B is the drag or air resistance and C is equal to the weight. Next, the question refers to the diagram of the triangle of forces here for A, B and C. You are asked to state and explain how this diagram shows that the helicopter is moving at constant velocity. You must refer to what the diagram is showing you here. So if we look at this diagram, we see a closed triangle of forces. So adding the lift to the drag to the weight leads us to where we started in our diagram. The triangle is closed. The implication of this is that the resultant force is 0, or the forces are in equilibrium. This is why it's moving at constant velocity, which is what we were asked to argue the case for. Next, we're told the value of the lift force as 9.5 kilonewtons, and we're pointed to the angle that it's acting at, 74 degrees to the horizontal. We now need to calculate the weight of the helicopter. To do this, we need to resolve forces in the vertical direction. The drag will have no impact in the vertical direction whatsoever, so we only need to consider the lift and the weight. The vertical component of the lift will be equal and opposite to the weight. So we're going to resolve this force into the vertical direction. You may be able to look at this diagram and instantly say that the vertical component is equal to A sine 74, or you may say A cos 16. If not, then draw a clear diagram showing both the vertical and horizontal components at right angles to each other. Then you can just use your trigonometry to get an expression for the vertical component. So finally, to solve the problem, we have that the vertical component is equal to the weight. Be careful, the answer is marked as in newtons, so we're going to convert 9.5 kilonewtons to 9,500 newtons. Finally, notice that you've been asked to state your answer to an appropriate number of significant figures. Looking at the data given in the question, we have 2 significant figures, so we leave our answer also to 2 significant figures, 9,100 newtons.